What's up, coders? It's been a while. I missed you. Hope you are doing well. It's the first time I haven't uploaded for so long, so thank you for staying with me, and to new subscribers, welcome aboard. So I was optimizing some images for the web the other day using this website compressor.io and came across this image comparison slider and thought, this would be an interesting component to implement. But then I also noticed this tilting effect while hovering over the slider. So here's the deal. Today we will implement the tilt effect on mouse over, and in the next video we will go ahead and create the image comparison slider. For the tilt effect, we will first use a small library called vanilla-tilt.js, which is more than enough for this task. However, this would be too simple, so we will also implement the tilt effect on mouse over from scratch without using any libraries. I hope you will enjoy this video. Don't forget to like, it's a small gesture but really means a lot, and subscribe if you haven't already. Okay, let's go! Starting with an empty project in our Visual Studio Code editor, let's create the index.html file. In the index.html file, I type exclamation mark, says Emmet abbreviation. VS Code comes with the Emmet plugin embedded, so we don't have to install it. And if I hit tab or enter, we get some HTML5 boilerplate code to begin with. Let's set the title to tilt effect on mouse over with vanilla-tilt.js. And sooner or later we will add some styling, so let's also create the style.css file and link it to the document. For the body, let's try to keep the markup to a minimum, so body will be the main container. We won't add some other container element, and for now let's simply add a div element with the class, let's say card. Could be box or panel or button or whatever. Now let's open the project in the browser to see what we've created up to this point. For this purpose, I'm using the live server, which is a Visual Studio Code extension that allows for live reloading. As expected, we can't see anything since our cart element doesn't have any content or styling. So let's move on to our CSS file and add some basic styling. I usually start with resetting margin and padding to 0 and box sizing to border box for all elements. For the body, we will use flexbox in order to center its content vertically and horizontally. For this purpose, we set its width to 100%, which is the default anyway, since a flex container behaves as a block level element, and we set its minimum height to 100% of viewport height. And for the card, let's set width to 400 pixels, height to 500 pixels, and background color to this dark pink color. Okay, apparently we don't get the tilt effect by hovering over the card, so let's see how we can use the vanilla-tilt.js library in order to do this. Let's search for tilt.js. Here we are, vanilla-tilt.js. Notice that the tilt.js library also exists, which does the same but requires jQuery. We are interested in the vanilla JavaScript version. I will of course include a link in the description. So it is a smooth 3D tilt JavaScript library forked from tilt.js, the jQuery version. It is smooth, lightweight, 60 frames per second, vanilla JavaScript, no dependencies, and easy to use. In order to include it into our project, for example, the minified version, we could do it locally by right-clicking and saving the file as, or we could click on it and copy and paste the code in a file which we could name vanilla-tilt.min.js, or, and let's take this approach, we could use a CDN. So in the cdn.js.com website, let's search for the vanilla-tilt library, here it is. And for the minified file, let's copy the URL, and in our project, at the end of the body, right above the closing body tag, let's include the script, setting its source attribute to that URL. All that remains now is to define which element or elements of our page will have the tilt effect. We can do this either by adding the corresponding HTML data attribute or attributes if we also want to change the default settings to the tilting element or elements. This requires no JavaScript. I guess that's why it is called the easy way, although they are actually both easy. Or we could use JavaScript in order to initialize and configure the tilt effect for the tilting element or elements. Now, starting with the easy way, the absolute minimum in order to have the tilt effect with the default settings is adding the data tilt attribute to our element. Let's do this and check the result. Very nice. And that's all it takes. Of course, the card doesn't have to be empty, so let's add some content. An H1 heading with the text coding and an H2 heading with the text journey. Okay, and let's also add some basic styling in order to center the content, increase font size and set its color to white. And let's set flex direction to column instead of the default, which is row. Okay, now if we are not satisfied with the default behavior of the tilt effect, we can change the default values for various properties using the corresponding data attributes. For example, let's change the default max tilt rotation from 35 degrees. Actually, I think the default is 15 degrees, but here it says 35. Anyway, let's change it to 50 degrees so that the tilt effect will get more aggressive or intense. Indeed, tilting is getting a bit wild. And also notice that by increasing the tilt rotation, we also increase the probability of encountering this glitching, which will also be more intense while hovering close to the boundaries of the element. So that's something to consider. Let's change one more property and then accelerate. So besides changing the max tilt rotation, and let's set this to 30 degrees by the way, we are also changing the scaling of the tilted element to 0.8. In other words, we are scaling it down to 80% of its initial size. The default value here is of course 1. This is the result. Or we could scale it up, let's say to 1.1. Nice. Feel free to explore and experiment by changing values for the various properties. Here are a few more examples. The basic usage, we've been through that. Creating a parallax effect, we will come back to this in a bit. Glare effect, reverse tilt, which reverses the tilt direction, keep floating, full page listening, scale on hover, we've already been through that. We can also have a starting position, disable x-axis, disable y-axis. In this case, for example, tilting occurs along the x-axis. We also have the destroy method, which we can call in order to remove the tilt effect. And we can of course re-enable it by reinitializing. Finally, the tilt change event is available so that we can add an event listener for this event and do stuff when it occurs. Now, in order to create a parallax effect, we need to set the transform style property to preserve 3D for the tilt element, which in our case is the cart element. This way, we specify that transformed child elements will preserve the 3D transformations. Default value for this property is flat, by the way. This must be used together with the transform property. So initially we will set transform for the tilt element to perspective with 1000 pixels distance in order to be consistent with the perspective value here, which will be the dynamically added perspective while hovering. So these values should coincide. 1000 is the default. You can consider the perspective value as the distance between the user and the object. So the lower it is, the more extreme the tilt gets. Okay, let's set transform for our cart to perspective with distance set to 1000 pixels. The final step in order to get the parallax effect is to elevate the inner or child elements. As you can see, they are currently moving with the container element. Notice, for example, that they always remain exactly at the center, since everything is currently on the same level. For this purpose, we will reposition the inner elements along the z-axis using a positive value for translate z, moving them towards the viewer so that they pop out. Okay, we've set the transform property to translate z by 50 pixels for the inner elements. Alternatively, for our example, we could use the child combinator in order to select all direct children of the cart. Okay, let's save and check the result. Very nice. And we could, for example, elevate the H2 element even more, moving it even closer to the viewer by increasing its translate Z value, let's say to 100 pixels. As expected, we now get a more intense movement from the H2 element. Okay, and finally, let's see how we can initialize and configure the tilting elements with JavaScript instead of using the HTML data attributes. Obviously, after removing the data tilt related attributes, we don't get the tilt effect anymore. So let's move back to documentation, copy this JavaScript code snippet and move back to our HTML file. We won't create an external JavaScript file for this purpose since it's just a few lines of code. Instead, we will include the code here within this script tag. And for starters, we will simply initialize the tilt effect for the cart, keeping the default behavior. And as simple as that, again, we get the default tilt effect. If we also wanted to change some of the default options values, all we have to do is to add as a second argument of the init function the settings object containing the properties or options or settings that we want to change with the corresponding values. Similarly to the previous example, we are setting the max tilt rotation to 30 degrees, scale to 1.1, and in addition, we enable the glare effect and set the max glare opacity to 0.5 or 50%. Let's save and check the result. Looks nice. And maybe in order to make the glare effect a bit more obvious, let's set the background color of the body to black. Nice. Now, if we had more than one card elements for which we also wanted the tilt effect, normally we would have to select the elements and loop through the node list in order to initialize the tilt effect for each element. However, vanilla-tilt.js makes our life easier by also supporting node list here. Excellent. The tilt effect seems to be working fine for all of the cards, but let's add some space between the cards by setting the justify content of the body, which is the container element, to space, let's say space evenly, and why not, let's also set border radius for the cards to 1 rem in order to round the corners a bit. Okay, I like the result, but a small detail you might have noticed is that the card border radius does not apply to the glare effect, for which we don't get rounded corners, and that's because vanilla-tilt.js creates a separate element for the glare effect with the class JS-tilt-glare placed on top of the tilted element. One way to fix this would be by setting overflow to hidden for the card, which indeed fixes the issue, but it also removes the 3D effect for inner elements, since the transform style property is forced to flat. So if we wanted the tilt effect plus the parallax effect plus the glare effect plus rounded borders, instead of setting overflow to hidden for the card, we could target the glare elements directly and set their border radius to inherit, so that value is inherited from the parent element. And we get the parallax effect back. We won't expand any further on vanilla-tilt.js library, which, as we've seen, is a great option for enabling the tilt effect into a project. The current minified version is less than 10 kilobytes, about 8.5, so overall it is a great choice. We will, however, also implement the tilt effect from scratch for educational mainly purposes, but also as an alternative solution. But before proceeding, let's take a peek on how vanilla-tilt.js handles the tilt effect. So let's inspect and refresh the page. And let's concentrate, for example, on the first card, the pink one. And that's interesting, by the way. Now it is like discovering hidden secrets on the page. But anyway, let's stop playing. So this is our card with its initial styling. Initially, transform property is set to perspective 1000 pixels. And now let's see what happens when we hover over the card. As we can see, while hovering, styling of the card is changing dynamically. Wheel change property is set to transform. I'm not sure whether this is necessary though. Let's concentrate on how the transform property value is changing. So perspective is set to 1000 pixels and scaling to 1.1. according to our settings, and they remain unchanged throughout the entire hovering. Rotate X and Y values, however, keep changing according to the mouse position relative to the center of the card. The closer we are to the center, the less the rotation. For example, now we are really close to the center, and that's why rotate X and Y values are close to 0. Let me try to move vertically so that rotation mainly happens around the X axis. Notice the rotate X value ranging between -30 and +30 degrees. Recall that we've set max rotation to 30. And similarly for rotate Y. Finally, notice that the closer we get to the corners of the card, the closer we also get to max rotation for both X and Y. As soon as the mouse leaves the card, the transform property value resets to perspective 1000 pixels, rotate X and Y to 0 degrees and scale back to 1. So in the end, it all boils down to calculating the rotate X and Y values according to the mouse position relative to the center and forming the transform property value. Finally, notice that on mouse enter as well as on mouse leave, a transition is added to the card and removed after 300 milliseconds, which is the default speed for the transition. Otherwise, this would happen instantly. And in order to make this more obvious, let's slow down the transition by setting its speed to 5000 milliseconds, 5 seconds. Watch for the card styling, this is where transition will be added. There you have it. And after 5 seconds, it goes away. Also notice that although transition is still active for the first 5 seconds, tilting is still happening relatively smoothly. And that's due to this specific cubic Bezier easing function which responds quite quickly. If, for example, we set easing to linear, then things won't be working as smoothly. So the easing function matters. Okay, now that we have a rough idea on how we could approach the problem, let's move on to implementing the tilt effect from scratch. If you are up for a challenge, you can pause or exit the video and try to do it yourself, and you can always return later. In the meantime, let me create a new clean project and with the power of editing, come back to you in a sec, which by the way is exactly the time you need to smash the like button. Alright, we are back. This is our starting point for the tilt effect on mouse over, this time from scratch. Similarly to previous example, we start with a single div element in the body with the class card and link the style.css file to the document, which currently contains the exact same styling we've used before. I literally just copied and pasted these 30 lines of styling. Not everything is necessary yet, since we don't have any content for the card and we only have one card, but eventually will be. This time we'll use an external file for JavaScript, so let's create the main.js file and link it to the document. And let's open the project in the browser with live server. Nice. I would just prefer to remove border radius, at least for now, so that I will be able to hover as close to the corners as possible. Okay, and it's time to move to our JavaScript file and implement the tilt effect. For starters, let's get the card element and store it into a variable for easier access. And let's go straight for the main functionality, which is the tilt effect when the mouse moves over the card, and deal with the rest as they come. So we are adding an event listener over the cart element for the mouse move event, which occurs each time the user moves the mouse over the element even by 1 pixel, and whenever this event occurs, the cart mouse move function will be executed. We will implement this function right now. And the most demanding task here is to calculate the rotate X and Y values according to the mouse position relative to the center of the cart. So let's start by calculating the position for the center, the X and Y coordinates. I just pasted this part. Let's go through. We first need the cart dimensions, the width and height. And for this purpose, we are using the offset width and offset height properties over the cart in order to get them, in pixels by the way. And in order to get the center, let's take the X coordinate for example. We also need the left position of the cart. So center X would be equal to the left position plus width divided by 2. And similarly, the Y coordinate of the center would be equal to the top position of the cart plus height divided by 2. In order to get the left and top position of the cart, again in pixels, we are using the offset left and offset top properties over the cart respectively. By this point, we should have the coordinates for the center of the cart. Let's log them in the console. So by hovering over the cart, we get 960 pixels for X and 315 for Y. If we resize the window and hover over the cart, we get these new coordinates for the center. Okay, let's proceed. Next, we want to get the mouse position relative to the center of the cart. Starting with the X coordinate, we can use the client X property over the event. We are talking about the mouse move event, of course, in order to get the horizontal or X coordinate of the mouse pointer and subtract the center X value so that we get the position relative to the center. And let's log mouse X in the console and hover over the cart. Okay, now for example, mouse X is equal to 0, which means that we are at the horizontal center of the cart. At this point, event.clientX is equal to center X. Obviously, if I could move exactly vertically, then mouse X value would remain the same. And finally, notice that mouse X ranges between minus 200 pixels at the left edge of the cart and plus 200 pixels at the right edge. Well, actually plus 199, I guess that's because we also have the 0 value. Recall that the total width for our cart is 400 pixels, so the maximum absolute value for mouse X is 200 pixels, or by generalizing, width divided by 2. And similarly, we set the mouse Y position relative to the center of the cart to be equal to the vertical or Y coordinate of the mouse pointer minus the Y coordinate of the cart center. If we log mouse X and Y values in the console, we can see that when hovering close to the center, both values are getting close to 0. Mouse X value is increasing, I mean in absolute terms, when getting closer to the left and right edges, and mouse Y when getting closer to top and bottom. Finally, the closer we get to the corners, the closer we also get to maximum values for both mouse X and Y. Finally, we can proceed to calculating the rotate X and Y values, starting with rotate X, which is the rotation around the X axis. So in this case, we are interested in the vertical mouse movement. We know that mouse Y divided by half of the cart height will range between -1 and 1 according to the vertical mouse position over the cart. and we want to multiply that by the max tilt rotation. Let's hard code it for now to 25 degrees. And similarly, we set the rotate Y value. In case we want to reverse rotation direction later for either rotate X or Y or both, we might need to multiply by -1, but let's implement the transformation first and come back if necessary. Okay, time for the fun stuff. Let's form the transform property value for the cut and make it tilt. We'll use template literals. First, we add the perspective in order to get a 3D transformation. Actually, you know what? Let's ignore perspective at first in order to see the difference and only set rotate X and Y. Let's check the result. Okay, we do get the tilt effect, which however is not as graceful as the 3D version, at least in my opinion. So let's add perspective to our transformation, again hard coding the value for now. Very nice. The tilt direction, however, is not exactly the same as the default tilt direction we've seen in vanilla-tilt.js library. Rotation around the x-axis is the same. We should, however, reverse direction for rotation around y-axis. All we have to do is to change sign here, or to be more clear, to multiply by -1. Same way we are multiplying by +1 here. Totally unnecessary, I know. I just want to show that if, for example, we wanted to implement a reverse option, this is where we would set rotation direction, by multiplying by plus or -1 accordingly. And if we wanted, we could also control rounding. Using, for example, the toFixed method, let's round to 2 decimals. This would work, however, I would prefer to enclose this entire expression within parentheses, just in order to have a clearer visual separation of different parts. Okay, we now have the desired tilt direction. Let's also change scaling. Scale CSS function only scales in 2D, so let's use the scale 3D instead and scale up to, let's say, 1.3. And by hovering over the card, indeed its size increases. You might have already noticed that card does not reset back to its initial state when the mouse leaves the card. We'll deal with it in a while, but first, let's use variables for the various tilt effect properties instead of hard coding their values to different places in our project. We'll group the tilt effect related properties within an object. Let's call it tilt effect settings. And let's set max to 25. This is the max tilt rotation in degrees. Perspective to 1000. This is in pixels. Note, by the way, that this value should coincide with the perspective value here in our CSS file, which defines the initial state. As soon as the mouse moves over the card, this perspective value comes into effect. So I guess that if we only wanted to set perspective in one place, we could get the CSS value here with JavaScript. Using a CSS variable for the perspective value would simplify things, but we won't get into that now. And finally, let's set scale to 1.3. Now let's replace hard-coded values with the corresponding tilt effect settings object property values. Okay, I changed line here so that everything is visible. Normally I would just use one line, and let's see the result for these settings. Looks nice, and if we set max tilt rotation to 50 degrees, as expected, tilting is getting more extreme. Let's set max back to 25 and scale to 0.8. Card is now shrinking on mouse over, and if we set scale to 1, size remains the same. If we set perspective to 500 pixels, and by the way, let's leave the initial CSS perspective value unchanged for this example, as expected, tilt effect is getting more intense since we now have less distance between the viewer and the object. Okay, let's set perspective back to 1000 and scale to 1.2. Next, let's reset card back to its initial state when mouse leaves the card. For this purpose, we'll add an event listener over the card for the mouse leave event. And whenever this event occurs, the card mouse leave function will be executed. Let's implement this function. All we want to do here is to reset transform value back to initial perspective, rotate X and Y to 0, and scale to 1. Let's check the result. Indeed, on mouse leave, cat resets back to its initial state. Now, instead of having this instant jump when mouse enters or exits the cat, we could smoothen the transition, and let's first try doing that by adding a transition to the cat. For the transform property with 300 milliseconds duration, and let's keep the default timing function, which I think is. Okay, let's specify it, why not? This kind of works, but there is a delay in responding to mouse movement. This delay, however, could get even smaller or even insignificant by using a more appropriate timing function. Let's use, for example, the same function we've seen in vanilla-tilt.js library, which executes the main part of the transition effect in the very early stages of the transition. Much better, transition now responds significantly faster to mouse movement. I guess this solution could be acceptable, but I think the approach we've seen in vanilla-tilt.js makes more sense. So instead of adding transition to the cat, which will be active the entire time, we'll only be adding and removing the transition when the mouse enters or leaves the card. So let's also add an event listener for the mouse enter event, which will trigger the cart mouse enter function. And the only task of this function is to call the setTransition function, which we also want to call on mouse leave. Let's implement setTransition right now. So on mouse enter and mouse leave, the setTransition function will be called in order to set transition to, and let's use the same transition settings we've used previously, and 300 milliseconds later, which is the transition duration, we want to remove the transition by setting its value to an empty string. Okay, let's check. Looks fine. We do get the transition on mouse enter and mouse leave. And if we inspect, notice by the way the rotate X and Y values changing on mouse move, and when mouse exits or enters the cart, the transition is added and removed after 300 milliseconds. But this is happening quite fast, so let's increase transition duration to 3000 milliseconds. So on mouse enter, the transition is added and 3 seconds later it goes away. Same thing happens on mouse leave. Now, a small issue that could come up, and the longer the transition duration, the more probable it will, is when user gets in and out multiple times very fast before transition is removed. It won't take long. Actually, in this case, it will take about 3 seconds before transition starts behaving unexpectedly. And that's because each time the mouse enters or leaves the cart, a set timeout is added, which will remove the transition in 3 seconds. So now transition could be removed at any time. We don't have any control over it. In order to deal with this in the setTransition function, we could first clear the timer set with the setTimeout method before proceeding. For this purpose, we'll use the clearTimeout method, which takes as an argument the ID value of the timer returned by the setTimeout method. This is numerical, by the way. Now we could use a global variable for this, which however would get a bit more complicated if we had more than one cart, and in any case we should in general try to avoid using global variables when possible. So instead we'll store it into a cart element object property, and let's name this custom property transition timeout ID. We are allowed to do this. We should just be careful to avoid naming collisions. And finally, let's pass the cart property value as an argument to the clearTimeout method. By the way, if the argument value is null or undefined, which will be, for example, the case at the first time of execution, clearTimeout won't have any problem with that. It will not throw some error. So whenever the setTransition function is called, we first cancel the timer and start fresh. Let's check the result. Now, no matter how hard we try to break the transition, it consistently behaves the way it is supposed to be. Finally, instead of setting the entrance and exit transition duration and timing function here, we could do it in the tilt effect settings object. So speed will be a number defining the transition speed, or actually the transition duration in milliseconds. I'm just using the same corresponding property names we've seen in vanilla-tilt.js, and easing will be a string defining the transition easing function, the timing function. And let's replace hard-coded values with the corresponding tilt effect settings object property values. And let's make sure that everything still works fine. Yes, we do get the entrance and exit transition with half a second duration. Recall that we've set speed to 500 milliseconds. Tilt effect looks nice. And we don't get any errors in the console. Okay, let's not expand any further. If I kept on working and improving this project, my next step would probably be to better control, to actually reduce the frequency in which the mouse move event fires by either using some counter or even better using the request animation frame method. Next step could be to add more options to the tilt effect settings object, and next we could even make the tilt effect work for touch events as well, not just mouse events. Feel free to build upon this project and expand. Our card, of course, doesn't have to be empty. Let's add some content. We already have the styling in our CSS file. Very nice. The parallax effect works because of this, the transform style property set to preserve 3D for the card, and of course due to this styling for inner elements, but without this it wouldn't work. And finally, let's add two more cards. As expected, the tilt effect currently only applies to the first one, since the query selector method only returns the first element within the document that matches the specified selector. So let's use the query selector all method instead in order to get all cards, actually a node list with all the card elements. Let's also change variable name to cards instead of card, and next step is to loop through the node list of cards. We can do this with the for-each method and add the event listeners to each card. All that remains now is to specify that the card in our event listener functions is actually the card whose event listeners triggered the event. So we set card to event.currentTarget. That's all for the card mouse move function. For card mouse leave, again, let's replace card with event.currentTarget and pass event to the set transition function so that we can access the current target. Let's do the same here for the card mouse enter function. And finally, for the set transition function, which now takes event as a parameter, again we set card to event.currentTarget. And that should be it. Let's save and check the result. Excellent. Tilt effect is successfully added to all cards. But one issue I've just noticed is that rotate X and Y values can exceed the max tilt rotation, which is currently set to 25 degrees. For example, tilting in this area close to the corner is consistently happening beyond the acceptable range for both rotate X and Y. That's not necessarily bad, since not strictly restricting the rotation allows tilting to keep happening until the very last pixel. But in any case, let's examine why this is happening and fix it, in the sense that max tilt rotation should be exactly that. Obviously, the issue is in the rotate X and Y calculation, and more specifically in this quantity here, this ratio for both X and Y. We've assumed that this would always range between plus and minus 1 at any point of our card, which would be the case if there wasn't any tilting and or scaling, and more specifically scaling up. In such a case, it would be possible to get values greater than 1 for this ratio, I mean absolute values, and therefore range could get wider than plus and minus 1. So, in order to ensure that rotate X and Y will never exceed the max tilt rotation, we must first check whether this value of the entire expression exceeds the limits, and if it does, we set rotation to the max tilt rotation value, positive or negative accordingly. Otherwise, if it is within the acceptable range, we set rotation to this value. In order to make things easier to read, let's store this value into a variable. I guess we could name this variable rotate X temp, but let's give it a more meaningful name. Let's name it rotate X uncapped, or unrestricted, or unbounded. I hope this makes sense. And we don't need the two fixed rounding for now. Let's remove it. And let's do the same for rotate Y uncapped. Finally, let's set rotate X and Y. Starting with rotate X, we'll use the ternary operator. So if rotate X uncapped is less than minus max tilt rotation, in this case we set rotate X to minus max tilt rotation. Else, and let's open parentheses here since this will actually be a nested ternary operator, let's also change lines so that you can see everything. I don't normally change lines for these things, but I'm getting out of my comfort zone for you guys. So, else, if rotate X uncapped is greater than max tilt rotation, this is the positive value now. In this case, we set rotate X to max tilt rotation. Else, in this case, rotate X uncapped is within the acceptable range. So, we set rotate X to rotate X uncapped. And at this point, you could specify rounding if you wanted. And similarly, by simply replacing X with Y, we set rotate Y. Okay, that should do it. Let's save and check the result. The tilt effect seems to work fine. And this time, indeed, X and Y rotation never exceeds 25 degrees, which is the max tilt rotation. So, for example, by hovering over this area close to the corner, we don't get any additional tilting since rotate X and Y values are already maxed out. Okay, everything now works as expected. We don't get any errors in the console. So I think this would be a good point to wrap it up. Here's a small example I've put together in order to compare the tilt effect with vanilla-tilt.js and the one we've just implemented from scratch. Both cards share the exact same styling except for the background color and the exact same tilt effect configuration settings. I will include, by the way, a link to this example and of course to the main project we've just created in the description. And I think that the tilt effect in both cases looks quite similar. But I would love to hear what you think, so feel free to share your thoughts in the comments section below. That's all for now guys, thanks for watching. I hope you enjoyed this video and got some value out of it. If you did, please hit the like button and share it with anyone who might be interested. If you want to help me keep trying to help you, don't forget to subscribe to this channel. Until next time, keep coding, keep improving, and enjoy the journey. Take care. Bye.